So far, we looked at partial fractions decomposition for non-repeated factors. Um, Next case is it's a product of linear factors, but some are repeated, which means we're going to use a1 over x1 plus b1 plus a2 over x1 a1x plus b1 squared until the highest power of repetition. Okay, let's look at an example. Again, here the degree of the numerator is more, so we first perform division. I'm going to leave you to perform the division. When you do so, you should get this to be the quotient, and you get this to be the remainder. Okay, now let's try to factor the denominator. The denominator, first of all, I notice that q of 1 is 0, so x minus 1 is a factor. And qx comes out to be x minus 1 and x squared minus 1, which is x minus 1 squared times x plus 1. So in this case, because this is repeating, there's going to be two contributions of this in the expansion. One with the power 1 and one with the power 2. So this is what it means up here by until r, the highest power. So if this was a cubed, you would have a third term with a cube in the denominator. And then the process is the same. We multiply by the common denominator, both sides, end up with 4x, collect the terms. So here FOIL, and then you collect the similar ones. And you end up with getting an equation. So a plus c equals 0, giving you c is negative a. B minus 2c is 4. B minus a plus c, so b plus 2c is 0. Add these up, and you get 2b equals 4, giving you b is 2, and c is negative 1. So this is the decomposition, where that's a, that's b, and that's c. And the integration just becomes x plus 1, remember, is a quotient. So you get, that's direct. Yeah, you get the log. And in this case, you don't have to use the log, you just use the exponent formula, and so on. The next case is if the denominator consists of an irreducible factor. Irreducible factor would be something like x squared plus a squared, meaning it can't be factored further. Again, none of which repeat. So in this case, the difference is that now the numerator has to be ax plus b. So the way you can remember this is that the difference between the degree of the numerator and the denominator has to be 1. In the previous case, since the denominators were degree 1, the numerator could be taken to be constants. Because the denominator here is degree 2, they have to be taken as ax plus b. For example, right here, so these are two irreducibles. The first one behaves normally because that's a degree 1. The second and the third behave differently because these are irreducible. Okay, so that's how you would set up this particular problem. But let's look at a simpler example. Right here, you have one irreducible. The first contribution is normal, so it's a over x. And the second one is bx plus c because of the irreducible. Again, we multiply, FOIL, collect. When you do that, you get a plus b is 2, c is negative 1, a is 1. And so now you end up with a log integral and the second integral, which is not directly obvious. So we have to do some work for the second integral. For the second integral, we are going to have to split this, right? So I can write x minus 1 over x squared plus 4 as x over x squared plus 4 minus 1 over x squared plus 4. Now for x over x squared plus 4, I can actually u sub and make it a log integral by making u equals x squared plus 4 du over 2 equals x dx, giving me 1/2 du over u, which is 1/2 ln u, which is 1/2 ln x squared plus 4. And for the last part, I can use an arctan substitution where I let x equals say 2 tan theta and I solve. So I end up with this thing. Now sometimes another strategy is to rationalizing substitutions, meaning the integrate consists of forms of nth root of gx. What you do is you just sub that as u. For example, square root of x plus 1 over x dx, then you let u equal square root of x plus 1, then u squared minus 4 is x, 2u du is dx, and you end up with this term for which you can then use partial fraction. And because this is just u over 2, u minus 2 and u plus 2 by difference of squares. So this can be, well, you've put this as a and b, and when you solve, a is going to come out to 1 and b is going to come out negative 1, so that you end up with 1 over u minus 2 minus 1 over u plus 2. Right, you can verify this is u plus 2 minus u plus 2, so it's 4 over u minus 2 times u plus 2, so on. So they both become log terms, which when you have a subtraction, that is just, this is 2u plus 2 log u minus 2 over u plus 2, and you substitute u as square root of x plus 4. That's it. These are the integration strategies for this week.